Okay, so I'm going to continue with this relativization and talk about the absolute and relative Frobenius. Okay, so in the special case when, so let's take X, a scheme, let's say S has characteristic P. So the structure sheaf has characteristic P, or it's defined over a characteristic P field. Okay, so then, so this is we'll make a new notation. So let's say that F, so there's always, so whenever you have something in characteristic P, you always have a map like this. So this is the definition. So there's the Frobenius on variety, right? And so this is the unique morphism of schemes. Such that it looks like this on looks like Pth powers for things on the things. So this is called the absolute Frobenius. Okay, and so this is a morphism here. This is a morphism of Z schemes. So we have, this is it's just a morphism of schemes, that's all. You don't really say that it's morphism relative to anything. Okay, so this is the absolute Frobenius. There's one here, there's one on X, so since X is over S. So there's always one. And this actually fixes the morphism, okay? So there's also a thing called the relative Frobenius, and then the relative Frobenius is going to be, let me just say what this is, okay? So let me give you another definition. Okay, so from the previous video, we saw if we had an endomorphism of a ring, or I guess you can do it for a scheme, right? We're going to do this. So x to the p, okay, is going to be this. So it's going to be defined by the following fiber diagram. So this is f of s here. Okay, and sometimes we'll call this maybe curly phi. And so this is the Frobenius twist. Of x. Okay, and so all you're doing is base changing by the absolute Frobenius here. Okay. Okay, so what's the relative Frobenius? Okay, so what is the relative Frobenius? So here I'm going to write out a diagram here. So we have our Frobenius twisted guy, S here, and we have this Fs, and we have this phi map. So this is the structure map here. So here, okay, so the relative Frobenius is going to be a morphism here of, okay, so this guy's the relative Frobenius here. This guy exists and is the relative Frobenius. We call him the relative Frobenius. Okay, so there either exists a morphism of schemes. So this is a morphism here. This guy here is a morphism of S schemes. Okay, so now this is S linear. So before, if we were going to do the Frobenius on X, it wouldn't keep the base fixed, but now it will. Okay, and so in the notation of the previous things, okay, so we're going to have that sigma is going to correspond to f of x, okay, and sometimes we'll use a notation, so something like x sigma, so this notation that we had before is xp, okay, and so what we'll have in, okay, so this is some notation that we have. Let me go to the next page. Okay, so in this notation, so what do we have? So we have, so phi star, so that map, okay, so this map here, Okay, so what does it do to functions? So I'm going to now write it in terms of, let's do sharps, since I started with sharps. Phi star of f, or P sharp of f, okay? So this is this, like, pre-Frobenius guy, okay? So what it does is it's kind of like your Frobenius gun, right? So f here is an O of x, and you've not quite applied the Frobenius yet, right? So this is like, you've not done it yet, but then once you apply f of x over s to this guy here, then you get the pth power map. So it kind of takes away that thing, okay? And so this guy here lives in the structure sheaf of O of x to the p, right? So this guy's in O of x to the p, so if I had a superscript there. And then this thing is, again, this map here. So we went here, so this is like you're loading the gun, and then you shoot it. Something like that, okay? And so notice that, phi sharp composed with f of x over s sharp is this absolute Frobenius sharp, okay? So, yeah, so it's a factorization. So the relative Frobenius is just a factorization of your usual Frobenius. Sometimes people use the word geometric Frobenius. That means something completely different. So that's kind of the inverse of Frobenius when you're working over perfect fields. So, so that's all I wanted to say about this.